Welcome back. Let's go through this Build Your Understanding problem, looking at height and how tall you have to be, depending on your gender, to be considered tall or taller. Okay, so we're given that the average or mean height of a 20 to 29-year-old man is 69.6 inches tall. Standard deviation is 3.0. The mean height of a 20 to 29-year-old woman is 64.1 with a standard deviation of 3.8 inches. Now, I don't know about you, but when I look at this summary of what the information I was given, I worry that I'm not going to know which mu is which, okay, because I've used the same letter for them. So let me just remind you of a standard practice in math. I want to use mu and sigma because I'm used to those meaning average and standard deviation, but I've got two means and two standard deviations. So I'm going to use a subscript. How about M for men and W for women? M for men and W for women. So now I know not only that mu is the mean, but which mean it is. It's the men's or the women's mean. Okay, so going on to part A, who's relatively taller, a 75-inch man. So I need to compare these heights. I need the z-scores for each of them, and I'm going to use subscripts again. Z-score for the man versus z-score for the woman. And the z-score for the man is going to be, he's 75 inches tall, minus, let's see, mean for the men, I can tell this is men because of the M, minus 69.6 divided by standard deviation for the men is 3.0. So let's see, I get 5.4 divided by 3.0, that's 1.8. So this guy is 1.8 standard deviations taller than the average. What about the woman? Well, her height is 70. Average height for a woman, can I fit all this in? Yeah. Average height for women is 64.1. Standard deviation of the height for women is 3.8. So I'm going to be computing, let's see, it looks like it's going to be 5.9 divided by 3.8. That's 1.6. Okay, so she's only 1.6 standard deviations above average height for a woman. So relatively speaking, in terms of their genders, he is taller. He's got sort of a taller height status than she does for his gender than she does for hers. It's kind of interesting to notice here, if you look at the numerators, he's only 5.4 inches taller than average. She's 5.9 inches taller than average. Okay, so at first glance you might think, well, she's tall, she should be taller for her gender. But notice that women's heights appear to be more spread out. So because of the spread outness of the women's heights, it turns out there's still more women that are taller, proportionately more women that are taller than she is than there are men that are taller than he is, even though, you know, her height is, if you just look at the difference between her height and the average, it's a bigger difference. Okay, part B. Who's relatively taller, a 67-inch man or a 62-inch tall woman? So the z-score for the man versus the z-score for the woman, that's what allows us to compare them in a apples-to-apples sort of way, rather than trying to compare apples to oranges. 67-inch tall man minus the mean for the men of 69.6 divided by the standard deviation for the men. So now he's below average height. How much below? Well, this is going to be negative 2.6 divided by 3.0, and we get negative 0.87. So he's 0.87 standard deviations below average height for men in their 20s. For the 62-inch woman, 62 minus the average height for women, mean height for women in their 20s is 64.1. We'll divide by the standard deviation of 3.8. She is 2.1 inches below average, but we need to do a true comparison, we need to divide by the standard deviation to take into account how spread out women's heights are, and we get negative 0.55. So in terms of number of standard deviations, she is not as far below average as he is. So in this example, she would be considered taller, or maybe less shorter would be the way to say that, but I'll say taller because that's what the question asked us for. So again, what we mean by taller is there are proportionately more women that are shorter than her, or proportionately fewer women that are taller than her than there are for him and his gender. Okay, so I hope you are making sense of these z-scores and how you can use them to compare different types of variables.